Okay, let us discuss the next problem. This is again a derivation. This derivation is related to lateral displacement through a slab. Let us make the diagram and then we will discuss. So make the diagram. Okay, if you are able to do, let us discuss how we will do. So I have a ray, this ray is coming, this is a slab. Now this slab has a refractive index of n, and the outside refractive index is 1, and this side also refractive index is 1. So environment has a refractive index of 1 unit. Now the angle of incidence is theta A. Angle of refraction through the first phase is theta B dash, and angle of incidence on the second phase is theta B. Now angle of refraction through the second phase is theta A dash. Now first we have to prove, and thickness of slab is given T. The first we have to prove that is theta A is equals to theta A dash. So this we have to prove. Now you see, first thing, now this angle and this angle are basically alternate angle because this slab sides are parallel. So this side and this side parallel sides. This means this angle is equals to this angle. So I can write theta B is equals to theta B dash. Now if I apply sine rule, so let us say if I apply sine rule on surface 1, so this is my surface 1. If I apply sine rule here, I can write mu1, that is 1 into sine theta A, is equals to mu2, that is n, into sine theta B dash. Similarly, I can apply sine rule on the second surface. So this is my surface 2. So this is at surface 1 and this is at surface 2. So at surface 2. So this I am applying at surface 2. So if I apply, so n into sine theta B is equals to 1 into sine theta A dash. So simple, because angle of refraction is sine theta A dash. Now the third equation I can write, if I see theta B is equals to theta B dash, so this and this cancels out because theta B is equals to theta B dash. So this means 1 into sine theta is equals to 1 into sine theta A dash. So simply I can write sine theta is equals to sine theta A dash. This implies theta A is equals to theta A dash. Now you see, in this case, even if I have some refractive index here in place of 1, if I have some refractive index here and same refractive index here, so let us say refractive index is mu here, and here also have a refractive index mu. So what will happen? This mu will again cancel out. So we will get this theta A is equals to theta A dash again. So this means even if I dip this slab into a medium that has a refractive index mu, the result we are doing is still valid. So now even later we will see, this means lateral displacement that will find D will remain same even if I dip this slab into any medium, because the results we are going to say next, we will simply do the geometrical results now. We will apply the geometry, and the main result we have applied the sine rule. Here we can see this mu cancels out. Now things are very easy now. Now let us see this triangle AMP. this is a perpendicular D and this distance is D, that is the lateral displacement. So distance between two parallel lines is D. If I drop a perpendicular from this point to this extended line, the incident extended line, if I drop a perpendicular, this distance is D. Now let us say this distance AM is X. If this angle is theta B dash, this angle is theta A, so this angle is theta A minus theta B. Are you getting or not? You try yourself, you verify yourself. This angle is theta A minus theta B dash. Now in this triangle, if I apply sine rule, I can write this distance divided by sine of this angle is equals to this distance divided by 90 degree. So this means if I apply sine rule, I can write d by sine theta A minus theta B dash is equals to xy sine 90. So from here I can say xd is equals to x sine theta A minus theta B dash. Now again we can apply cos in this triangle. So you write, so if I apply cos in this triangle, so you see in this triangle this distance is t and this distance is x. This angle is theta B dash. So if I say in this triangle, so let us say if I extend and I see this triangle, and if I apply cos rule, I can say x divided by, so this distance t divided by x is equals to cos theta B dash. So if I write the same, I can write cos theta dash is equals to t by x. So from here x is equals to t by cos theta dash, theta B dash. Now if I plug this value of x into the previous equation, equation number 3, we will get d is this value. Now this is the result for lateral displacement. So d is equals to t by cos theta B dash into sin theta A minus theta B dash. So the theta B dash is same as theta A dash, theta B. So this means now if I know the theta A and theta B dash, we can calculate the lateral displacement very easy. Now theta B dash, generally we know theta A, but we does not know theta B dash. So what we will do, we will apply the sine rule, the first equation, and find theta B. So are you able to write or not? Just wait 1 minute. So write down. And now calculate for this case what will be the delta. You have what will be the d. So in this case you have to calculate d yourself. What will the value of d? You calculate yourself. I have not calculated. So you know you have to calculate theta B dash first, because theta A is given but theta B dash is not given. So you can calculate theta B dash easily from the equation number 1. Sin theta A you know, n is you know, that is 1.66 in this case. So you will get sin theta B dash. So theta B dash you know. Now if you plug the value of theta B dash, you will get the d. That is the important point. So you calculate this value d, and let us check with your friends, are you getting the same idea or not. You can take the help of calculator, because sin theta b will come out to be some value. You can approximate the value. It is coming out something closer to 30 degree, 40 degree, 20 degree. So you can have some approximation, otherwise you do the exact calculation by taking the help of calculator. Okay, we'll discuss the next problem.